So you survived chapter 1, and now we're into chapter 2. You're going to find that my videos are a little bit more, I'll do a lot more explaining on these. So let's start in with exponents, or some people say exponentiation, which I do not say that. When we talk about exponents, what we're talking about is taking a base, symbolized by b, to an nth power. So if you had 3 with an exponent of 4, you would say that's 3 to the 4th power. By the way, if you have any number, let's say 3 to the second, when you have something to the second power, a lot of times instead of saying second power, people will call that squared, 3 squared. And also, if I had something to the 3rd power, we call that 4 cubed. And that is because the reason why we call that square has to do with geometry. If you have a 2 by 2 array, notice it makes a square, a 4. A 3 by 3, it becomes 9. So those are called your perfect squares. Like your perfect squares are 1, 4, 9, 16, 25, 36, 49. I'm going to miss one because I'm trying to, 64, that's 8, 9, 10. Anyway, I require my students to memorize them all the way up to 20 for the squares and the cubes. This is more valuable than you realize, especially when they start factoring and they're doing special factors. If they recognize squares that quickly, it makes them a better student. Also, when they're trying to simplify the radical, knowing your perfect squares is pretty doggone important. So again, the b was my base, the n is my exponent or my power. And I like to emphasize to students that, like, if I have 2 times 3, when I'm multiplying, I'm doing repeated addition. That's 2 plus 2 plus 2. That's 6, right? Or you can say 3 plus 3 is equal to 6. Because multiplication is really just repeated addition. It's how many times you're going to repeat a number. But exponents are repeated multiplication. If I have like 4 cubed, that's the same thing as 4 times 4 times 4. And for the first few lessons in exponents, I make the students write that out. And the reason being is because they're going to do 4 times 3. Not every time, but like every other time. So I like them to do this, and of course that's going to be 16 times 4, which is 64. But I do like them to, I say write it out, but it's actually the proper term is expand it. Put it in an expanded view, expanded form. Okay, so the word squared actually comes from the geometry of squared. Cubed is when you're doing volume, which is length times width times height, that you're going to get cubic units. It's 3D. You've gone from 2D dimension to 3D. So that's where those two expressions are. They can say to the 3rd power or cubed. It matters not. There's nothing big about that. Okay, so as soon as you're doing you start doing the exponents, the textbook gets you into order of operations. So let's talk about some tricky stuff. First of all, I want to talk about negative numbers, because you're going to be squaring some negative numbers. There is a difference. Well, let me bring it up this way. Do you remember, please excuse my dear Aunt Sally, PEMDAS? It's the order of operations, and it doesn't go away. And of course you have to do parentheses and exponents first. And so I'm going to write a problem out. This is actually one from the worksheet. So using PEMDAS, you have to do this exponent before you multiply by the 5. If you multiply 5 times 2, you're going to get 10 squared, which is 100, and it's wrong. You have to do your exponents first. So I'm going to rewrite this as 180 minus 5 times 4. And of course, you have to do all the multiplication and division in order as they appear up here, left to right, before you move on to adding and subtracting. So this is 180 minus 20, and the answer is 60. But please notice that you have to do the exponents first, because that precedes multiplication. Another big problem in algebra is that students will say, oh, a negative times a negative, that's going to be positive. And they'll think that this is positive 144. But without the use of parentheses, I have to do this first. Putting a negative in front of a number is the same as saying I'm multiplying this by negative 1. This could be expressed like this, and it would be correct. And you do this 12 squared first, which is 144, and then you have to make it negative. It's negative 144. So let me show you the 3 ways you're going to see this presented in algebra. I'll use 5. Like sometimes you'll see negative 5 quantity squared. Sometimes you'll see negative 5 squared and negative 5 squared. If you see it this way, this is the same thing as, I'm going to expand it out, negative 5 times negative 5, which is positive 25. This is the same thing as negative 1 times 25, and it's negative 25. And this is negative 1 times 25, which is negative 25 again. So make sure that you teach that to your students. On the worksheet that you have, there's several of these. Let's say it's x squared plus 3x minus 2, and it'll say evaluate when x is equal to 2 and when x is equal to negative 2. So when x is 2, I would say, well, that's going to be 4 plus 2 times 3 is 6 minus 2, so the answer is 8. If x is negative 2, I'm going to expand it out for you. Negative 2 squared plus 3x minus 2 is equal. Okay, now I didn't write that the way I should have. When they're saying x is negative 2 and x is being squared, the function of x here is that it's being squared. This is the deal. So that's going to be negative 2 times negative 2 is 4, plus negative 2 times 3 is negative 6, minus 2. So of course I think this is negative 2 minus 2 is negative 4. So, but if you see this, negative x squared plus 3x minus 2, and they say x is equal to 2, you're gonna have 4 and make it negative. So this would be, because x is 2 and x is being squared, and then because it comes second, a negative is applied, then that will be negative 4 plus 6 minus 2, which I believe is 0. Negative 4 plus 6 is 2 minus 2 is 0. So there's there's quite a few practice problems in the book, also on my worksheets, that cover that. And so you really have to explain that to the student. They really have to practice it. You may want them to teach it back. if you have a student explain it back to you or teach it back to you, then their brain has to process it a whole different way than just doing it. And so that is more meaningful, more reinforcement. Okay, one more thing before I end this. Another property that comes up in the first section is this. It teaches you about a squared times b squared, having two different bases, but both of them being squared. Notice they're being multiplied. Is it true that you can just multiply those two numbers and square them? And it is. What about this one? Well, let's handle this one first, and I'll show you. Let's say you had 4 squared times 25 squared. Is that equal to 4 times 25? Because wouldn't that be easy? Squared. Well, let's expand it so that you can see it. This is 4 times 4. I'm going to use a dot. I don't like that. I don't like that color either. This is 4 times 4 times 25 times 25. This side is 4 times 25 for the first quantity, but I'm multiplying it twice. 4 times 25. Can you see what's going on now? It's just a rearrangement. So yeah, if you have two different bases and they're being squared and they're being multiplied, it's the same thing. So 100 squared, it's just 100 times 100, right? So you're just adding 2 zeros to that. And here, 16 times 625 is indeed the same thing, 10,000, excuse me. Okay, let's look at, does it work for adding? Let's use the same two numbers. We have 4 squared, plus 25 squared. And then you have 4 plus 25 quantity squared. So here, this is going to be 16 plus 625. You probably already know the answer. What is that, 641? Here, this is 29 squared. Okay, this is going to be, if this is 641, you can already tell, can't you? 29, think about it this way, 25 squared is 625. And 30 squared is 900. So you're getting on close to 900. So by the way, 29 squared is 841. And no, it's not any kind of coincidence that those are 200 apart. Let's do another one with plus. Let's say it's 2 squared plus 3 squared, and then 2 plus 3 quantity squared. Are they going to equal? Look at that crazy thing. Are they going to equal one another? So 4 plus 9, of course, is 13. This is 5 squared, and it's 25. And it doesn't, because you're adding. You're using two different operations. It works when you're multiplying, but not when you're adding. And that's a real important thing to teach your student. Okay. Wow, 13 minutes. You must be tired. Take care.